Okay, good morning all. I think that I can keep my talk this morning to roughly 30 to 35 minutes. I'm clicking on my screen, it's not going forward. So I will talk this morning roughly 5 minutes about Allegrograph. We looked at the list of people that are attending this talk, and we saw that most of them probably already have heard of Allegrograph. I'll just do it in 5 minutes. Then I talk about EC2, and again I guess that most of you already have looked a little bit at EC2, but again I will talk a little bit about it for people that never heard of it. Then I'll describe how we did some experiments with Allegrograph and EC2 where we ran up to 10 billion triples and did all kinds of queries on those enormous set of triples. So I'll talk about the data set that we had, how long it took to load the stuff. I'll talk a little about federation and about the queries that we did, and then about the future work that needs to be done in this area. So let's start with Allegrograph. Allegrograph is a scalable and persistent quad store. Up till now we called it a triple store, but like every triple store we do actually 4 elements per triple, so we better start calling it a quad store. We do federation, meaning that you can, on multiple machines or on the same machine, do multiple data loads in separate databases or triple stores, and then once you're done with your loading, you can create what we call an abstract triple store, which is basically just a pointer to a list of other triple stores, and then you do your sparkle or your reasoning or your prologue against that particular abstract store, and the abstract store will figure out where the triples are. And that gives you enormous flexibility on working with larger data sets. On the one hand, you could, if you do the telecom data like we do, you partition data over days, but we also have customers that put, say, ontologies in separate triple stores from their instance data or their facts, and then even the inferred triples go in different triple stores, so that it's a lot easier that when you change your ontology, you don't have to remove the old inferences from your main triple store, but you can just almost do what-if reasoning by using clusters of triple stores. And then, so we do federation, and then we comply with all the standards of W3C. So if you're working with another triple store, you can probably just load your data in our triple store, and if you work with our triple store, you probably can load your data instantly into other triple stores. What are the unique things of Allegrograph? Well, one of the most unique things is that we allow very, very efficient range queries. As most of you will know, a triple store doesn't work with the strings in the triples. What you actually do is that most of the time triples are just collections of numbers where the numbers point to strings in dictionaries and reverse dictionaries. We've gone for a different architecture where we still have pointers to strings in triple stores, but if we work with native data types like numbers or telephone numbers or latitudes or longitudes, then we will directly encode them in the triples, and then due to our indexing, we get competitive behavior when we do range queries with relational databases. Then on top of that, we implemented in the triple store a whole geospatial database, and I'll talk a little bit about that later. We made it a lot easier and very efficient to reason over time, and on top of that we worked, we created a whole library to do social network analytics, given that what many people do in the RDF community on the semantic web is actually have things that talk about things that happen in space, in time, and where you always have some actors that are related to each other, whether it's companies or people or what have you. So one of the new things that you can do with our triple store is what we call activity recognition. Given our combination of federation, social network analytics, the geospatial capabilities, the temporal capabilities. We now allow you to reason over events, and we can do queries like you see here. Find all meetings that happened in December within 5 miles of Berkeley that was attended by the most important person in Jan's friends and friends of friends. Now below you see how we do this query, how we express this query, and what you see on the right, that if you look at the first class, we actually do something with social network analytics, and the next rule is again social network analytics. Again, I'm assuming that people know how to read these rules and that they're familiar with Sparkle. Then we get a normal database lookup. We talk about a particular type of meeting, so we need some RDFS reasoning, and then we talk about something that happened at a particular time within a particular place. I don't want to go too deep today because it's about EC2, but we can now answer queries that combine all these things in one query framework, and we can do it on really large numbers of triples. So just a few words about social network analytics. We provide functions that will allow you to say how far a particular person is from another person, to what particular group a person belongs, how important a person is in a group, and whether a group has got a leader or no leader, and whether it's a strong group with strong connections or more like a weakly connected group. And on the spatial front, what we did is we are not like, say, at Oracle. We have really large libraries of geospatial primitives, but what we did is that we laid the foundation. So we made it very, very fast to do bounding box operations. So where you can say, okay, find all the triples, or find all the things, say, around Berkeley within 5 miles, and get answers very, very quickly back. And we make this work on a large scale. And then a lot of things what people do in our applications is actually work with time. And if you want to use our range capabilities within our triple store, then you could write all these functions that you see here on the right hand side yourself, but we decided to be nice to our community and write all these special functions and make them as efficient as possible, so you can directly use them on top of the data that you add to your triple stores. Now, we work with a number of government groups and agencies, and they need to work on really, really large scales. So being able to do these wonderful queries that I just showed you, on the one hand it's great that we can do the queries, but the question is, can we do these queries on really, really large numbers of triples? And so we've been looking at combinations of hardware that will allow us to do these queries. And there's a number of choices that you have. If you've got the money, the one thing you could do is you buy a Netezza box. I don't know if all the people know what the Netezza boxes are, but it's dedicated hardware where you have one big box with up to 1,000 hard disks in it, where each hard disk has its own little processor, and data is retrieved very, very efficiently. And Netezza is mostly for static applications where you do like data mining, but still it's a very impressive technology, and it allows you to do really, really large numbers. The other option is, an option that I like more, is to work with large memory machines. Doing queries or working with large amounts of triples works best if you have a lot of memory, because triple stores are very memory hungry, but again, they're very, very expensive. If you want to work with 10 billion triples and you want a good machine with a terabyte of memory, then you're anywhere between $200,000 and $1 million. Of course, you could take some stock hardware and build your own cluster to work with the 10 billion triples, and I would guess you need between $50,000 and $100,000. Or if you really want to play just for a few days with 10 billion triples, you can do what we did, is just go to Amazon's EC2 and do it for $192. Have 10 billion triples at your hands. So those are some hardware options, some options to run with really, really large data sets. Actually, going back, we are looking into large memory machines ourselves. We probably never will build our own clusters because EC2 is just too handy. But let's continue about EC2. EC2 probably started more than a year ago. It's just a really big hosting facility where you can, on demand, get more machines if your application needs it. Again, go to this website if you want to get all the details. If I just want to summarize the advantages of EC2, is that you get scalability in 2 dimensions. On the one hand, they have you can get as many machines as you need. Although if you need hundreds of machines, you probably better talk to Amazon first. And then they have the Starbuck model for machines, so you can get very small machines where you, and I forget the exact prices, but you pay just a dime an hour, to the really large ones where you pay 80 cents per hour. It's highly available. It's been one little period 2 months ago, I think, where it was out for a few hours, but for the rest it's been up all the time, and they're probably getting better and better to really guarantee high availability. They have wonderful bandwidth, and of course the big advantage of EC2 is there's no upfront investments. You just create instances in their cloud and you can start working. And well, here's what we did with our 10 billion triples. I didn't really look at the bill, but it would have been roughly $192. There are some problems with EC2. Right now, it's still the problem that if you create large data sets on their machines and then you turn off a machine instance, your data is gone. Or you have to copy it to S3, but there's no copy command where you can just say copy this data set to S3. You have to go through some interesting protocol, and it's still a little bit too clumsy, but Amazon just announced that within 2008 they will fix it so that you can turn off your instances and still have the data around. So we're looking forward to that. Now, if you want to run, I saw that there's a number of Allegrograph users in our audience, even for the ones that never have used it before. And what we did is we created some instructions on how to run Allegrograph on EC2. So here are some instructions. So this is on our website, allegrograph.france.com, and the page is ec2.html. And here we describe how you can obtain your Amazon EC2 account. Then the next thing is that Amazon has made it really, really easy to get going. They've created some software package that you can download, and once you've downloaded that, you get some tools that make it doable even for people that are not Linux gurus to start an EC2 instance. Then you can, so that's installing the EC2 command line tools. Then you can choose on what kind of operating system you want to work. They've got their own version of Linux or Unix. Then they have Fedora Core, and there's VM Linux. So you can make your choices on what you want to do. Then you just you generate a key pair, because you need to, of course, it needs to be an entirely secure solution. And then you just run your, what they call AMI, and then you can start going to EC2. I think I have an instance here. Let me go there. So I'm here within France in my own directory, and I can just say SSH EC2. And now I'm at EC2, and Amazon's EC2. And if I want to, and it's something that you probably most of the time won't do, you can go there and you can start an Emacs. Let me go there. So here's where I've got some files that I will show you later. And I can just start up an A-graph. Now for Java users, I'll tell you later how to do it, but require A-graph. Oops, EC2 is slow today. No, it's me. So what what I just want to show is CD. I can open triple stores on EC2, so let me open one triple store, say storage, I think it's metaweb.db. So if you are familiar with freebase.org or MetaWeb, it's this company in San Francisco that has this new idea where they take data sources from all over the world and turn them into a triple store, or something that resembles a triple store. So they take the Wikipedia, they take the IMDb, they take MusicBrainz, they take geonames.org for geospatial information, and what they then do is they do entity resolution, where they make sure that if you talk about a thing called Blade Runner, they will be kind of a definitive guide for what Blade Runner means, whether it's a movie or whether it's the director's cut of the movie or whether it's a song or the book. And each of these concepts will get a GUI ID, and they hope to be kind of the clearinghouse for concepts of the future. They make the triples available. It's closely to 100 million. I have it now running here on EC2. And I can do queries like, well, if I want to know about Kevin Bacon, it doesn't look much like RDF, but it still works in Allegrograph. So let me say, what can I say? Pretty print, subject, topic, English, Kevin Bacon. Oops. And so you see here a whole bunch of triples, all about the Kevin Bacon as an actor and a film producer and what have you. Now, of course, looking at triples in text is very, very handy for programmers, but if you really want to navigate, you probably want to do it slightly differently. So let me just go out and show you how our tool, our GUI tool directly can navigate in EC2. So let me do this, get out of here. And now let me go to my tool here. I have reloaded. So what I'll show you now is I go again to EC2, but I use our a GUI for navigating triple stores. So I do this, and then I say File, Open a remote triple store. I go to localhost. I have a secure tunnel set up to the triple store. I choose a port, and I use the name of the database that I want to open. So I can have multiple ones open. And then I could say, okay, I want to look at, say, again, topic, English, Kevin Bacon. So I have Kevin Bacon now as a node in this big triple store on EC2. I can look at the properties that I want to explore if I go here. So let me see, I found a nice one this morning, producer of. Let me see if I can find it again. Start. Where's the producer of? Kevin Bacon. Oh, produced by. Here's produced by. Do you see produced by here on the left hand side, Steve? Oh, here, produced by. Okay, so I can look at things that he produced. I can go from there. I can go to sex crimes. I can go there. So I'm not talking directly to EC2 on my machine here. Of course, I can also do the tabular views, and I'm looking at 6 crimes, and I see all the triples that you have here. And if I wanted to, I could just go here, and I can navigate through the triples. Oops, that was really bad what I did. I clicked on a link called person, and given that there's 200,000 persons in the triple store, it always takes a little bit to get them back. So never do that. Anyway, so you get an idea, and if I wanted to, I could even do Sparkle queries directly on my EC2 account. Yes, so I hope that is kind of clear. So let me go away from here, and let me go back to my presentation. So I showed you how to run Allegrograph on EC2. You can try it yourself. Then the experiment that we did was loading a 10 billion triples, where we looked at, we're working with a telecom company, and we have all these call detail records. So every time when you make a phone call, the telephone company stores who called, to whom you called, the callee, the owner of the line, the router you used, the cell you used. And so we got roughly 10 fields per line. It already takes 6 hours to load all this stuff up to 10 machines on EC2. So then what we took is 10 of the large instances of EC2. This is not the biggest one, because the biggest ones are 80 cents per hour. But for the experiments that we did, the large one was sufficiently enough, which takes 40 cents per hour. Then what we did is we handled 100 million call detail records per instance, where each 100 million call detail records will ultimately result up in roughly 1 billion triples. And then on each machine, each of the 10 machines, we did 4 parallel loads on each instance. So we basically load 250 million triples per load. And what we got is the following time. We got the total load time was roughly 3 hours. The total indexing time was 3 hours and 20 minutes, and the total time was just 6 hours and 20 minutes. Now, for people who have played with Allegrograph, this might seem fast, but one of the really cool things about telecom detail records is that there's hardly any unique strings in these triple store, in these fields. It's all native data types, so we don't have to build up large string tables, so we can just encode almost everything directly into the tuples or the quads, and that's why we get a really high speed. So we loaded 10 billion triples in 6 hours and roughly 6 hours and 20 minutes. Now, of course, if you take just enough EC2 machines, you could even load 100 billion or trillion triples. But what I always say now is it's not how many triples you can load, it's how fast can I get my triples back. That's far more important. So here's some timing data. If I take, say, so you have to realize there's 10 machines, each machine has 4 triple stores. So if I just say, and this database stores call detail records, and it will contain, so each triple store will contain some information about caller A. That's kind of completely distributed over all these machines. And so if I just want to talk to one triple store, one machine, and say give me all the calls from A to B, then it would take roughly 2 milliseconds. If I do this on one instance and I talk to the 4 machines, it takes roughly 8 milliseconds. But if I then do it on all the machines, so if I federate all the machines together, it will take 80 milliseconds. Now you might think that that's still really good, really fast, or that it's fast enough. The trouble is, of course, say you want to do some social network analysis, and you want to find the calls from A to B, and then from B to C, from C to D, and then from D to A again. Now you have to do a lot of expansions, and basically you run then in some kind of join problem, and then because you have to make this call so many times, suddenly performance is less than optimal. So we're still working on ways to make this join to come up with schemes where the join problem won't happen or will be less. And what we're working on is what we call informed federation. So well, there's many ways you can partition data. You can do it over time, or you can do it per predicate. So then if you know in your query that you call a particular predicate, and this predicate is only one particular file, then you don't have to look in 10 files, you can only look in one server and one file. And even you could do things on basis of type. And so there's all kinds of ways you can do that, and we're doing active research on this, and I guess that this year we'll probably give another talk or write a white paper or give some more information on how this will work efficiently. Now, I gave some Lisp examples. We do have, if you want to do some experiments, I guess that some people are familiar with our Learning Center. So if we just go to here, then if you want to play with federation, in our Learning Center for Java people, you can basically find how you do federation. And we expect in the next few weeks also to have some Java examples on how to do federation on EC2. So let's get back to my presentation. So again, we keep working on this, and what we really would be interested in is to see if there's any person in the audience that actually would like to have this as a service, because one of the things we could do is just could offer Allegrographs on EC2, and so you don't even have to install it, and you can just log into EC2 or just get an IP address, and then you can start adding triples and doing queries. Anyway, that's how I want to conclude my talk. Oh yeah, there was one question where someone said, how can I get Graph? Okay, so if you go to our website, then here we have Graph. agraph.france.com/graph, and then we have versions for Linux and for Windows.
So there's a question, can Graph be used to graphically construct a query?
No, not yet. Not yet.
But people can download it and use it with Allegrograph stores.
Yes. And ultimately we will be able to do queries with it. Right now you have to use Sparkle, but ultimately we will be able. But then again, there's some people working on tools like that. I mean, you've got Palantir here in the Bay Area that creates a wonderful GUI interface on top of triple stores. And they already have a wonderful interface for doing visual queries. I think that Top-Rate Composer is going a little bit in the direction of these types of queries, although I haven't really seen how far they go. We at France want to focus more on the triple store layer and the reasoning and the query languages. And the visual stuff is a whole different area of expertise. Another question, Steve.
Okay, well, right now that's the questions I have in the queue. Does anybody have any questions about what we presented today? Will the Linux version of Graph work on Mac?
No. We are getting closer to have our common graphics interface to work on Macintoshes, but we're not there yet. So we work on Graph and we work on Windows.
You should be able to use Parallels to have it work in Windows.
Yes. Oh, sorry. Well, if you are a Macintosh user, then you can use, of course, Parallels and run this window thing, and then you still would have Graph on your Macintosh.
Do you have experience on your speed-up curves as the number of instances and machines grow?
Can you repeat the questions?
Do you have any experience with speed-up curves as the number of instances and machines grow?
Yeah, I didn't prepare that for this meeting, but we have done some experiments with the Lubin benchmark, where we have cut up the Lubin benchmark is a benchmark that contains 7 million triples and has an ontology of what a university is and the people in the university in types of paper, and it comes with a set of 14 benchmark questions. And we have been doing experiments where we cut up these 7 million triples into 1 to 20 chunks, and then we do questions against them, queries against them. If you run the queries on the same machine, then the slowdown is just a small percentage, and of course linear with the number of instances that you have. If you work with remote triple stores, meaning they're in the data warehouse or they are distributed over the web, you get web latency, and then performance gets deteriorates. But Amazon has a really fast internal networks. Part of the work that we're doing is doing these types of benchmarks and see what the right trade-off is between having really big machines and having a combination of machines. I mean, obviously, you could have if you have 1 million triples, you have 1 million machines, so you can load very fast 1 triple on each machine, but the queries will be very slow. And on the other hand, you can have 1 machine, and your cursor will be there already, so you will much better performance. But it's a trade-off. I actually think that get the biggest machines you can get with as much memory as you can get, because that is always better than be working on multiple machines. But for really large experiments, you probably want to get the biggest machines you can get.
Another question, what about reification? It seems like a more general question.
How reification works, or?
I think it might be how reification works in Allegrograph.
Oh, I might have that available. So we have, actually I can also give a small demo of how federation works in Allegrograph, but let's go to reification first. So don't watch your screen, otherwise you might get nauseous. Where is it? Oh, here. So we have a site database. Let me close the triple store. We have a site database with 220,000 triples, and it has got information about all kinds of things that site defines, including some information about terrorists. And so here I'm loading 220,000 triples, and I'm completely doing a full text index on top of it. So normally I would get roughly 20,000 triples per second, but with full text indexing it slows down considerably. So now I have the triples loaded, and I register my namespace. So C stands for this long namespace psych, and I can do queries like, okay, but every A, B, X, P where Osama bin Laden influences agent C, where C is friends B's. Anyway, let's not go too deeply, but this is a whole complicated ad hoc query that you can do with a graph, and then you get here your results on the left-hand side. Like A would be Navari, B, Essam already, he was an airline pilot in Islamic belief system. So now verification. So I can do a query like this, where I say, okay, find all the triples where Osama bin Laden influences an agent Z within a particular graph, and where the triple has ID, and then I add in Lisp add triple Blair beliefs ID. So this is our really simple is one form of very simple reification. So I do this query, and now I have a number of extra triples where Blair believes a particular triple, and now I can use this verification again in my query, so I can do exactly the same query I did here, except I now I also ask whether Blair believes this particular triple to be true. Anyway, I don't know whether that was the question, but it was a good way to show up the reification part.
Okay, so there's back on the EC2. Question on what sort of instance were we using? For example, like small 2 gigs of RAM or large?
Large. 4 processors, 8 gig.
Okay. any standard or high CPU instances? Is any standard or high CPU instances?
No, Amazon is actually very interesting because they give certain kind of guarantees about what the machine has. But if you run, I sometimes have the suspicion that they give you a better machine than you pay for, because we could sometimes got higher CPU speeds than we paid for.
What would be your current best advice on best federation strategies? Which triples to keep together, which to split up?
Well, we're doing with the telecom work that we do it on a day-by-day basis, because then you have to do it over time. But for other customers who work with combinations of ontologies and instance data, they actually make a combination where they put ontologies in a different triple store from the instance data, and they also make sure that inferences go in another place, because I mean ontologies, your facts are your facts, and they're usually expensive, and ontologies are cheap, and you can just change them all the time. And so if you make a change to your ontology, create some new classes or define something to be of a different class, then your inferences will change too. And very quickly you get a management nightmare if you put all your ontologies and facts and infer triples in the same triple store. It's much better to keep them in separate triple stores, because then if you change your ontology, you just throw away the other infer triples. Then the question is about licensing. Is it licensing of Allegrograph?
For just an EC2 temporary clusters.
Okay, so what we really would like to is to talk to some of you guys that are interested in licensing. We're normally used to sell a license to Allegrograph in the triple store, but we're willing to do a deal where we actually license Allegrograph for a temporary time on EC2. But we haven't gotten to any particular price point yet.
Yeah, when the persistence is available, that's when we're going to have.
Actually, that's true. So right now, the issue is that we can offer we could offer you a license to work on EC2 and make it a temporary license. The one thing that you really have to be aware of is that you can create a big triple store on EC2, but you better not turn off your instance before you copy the data to like S3 or to your own machine. But if you're willing to do that, we will be instantly willing to talk to you about temporary licensing of Allegrograph.
Okay, well that about wraps up.
By the way, people should also be aware. Of course, there's a free download where you can do 50 million triples per triple store. So you can work with that free Allegrograph on EC2, and what you can do is you can buy as many EC2 instances and work with as many EC2 Allegrograph instances that you want to. Except each little triple store will hold only 50 million triples.
That sounds like fun. Okay, well that's up the questions. I'm going to be sending out a survey after this. Hopefully we got a good recording. I'll get it posted and let you know as soon as it's up and available, probably by tomorrow. In the questionnaire, I'm going to add some new questions. We've been busy adding new features and building a Allegrograph, and now we want to take a step back and try to get some feedback from you about usability, your experiences with working with it, maybe some insight into what you're doing with it. That was always helpful to help us plan going forward. Anything we can do to make the product more usable, we're very keen to hear that from you. So with that, thank you for attending. Again, thank you, Jans. I'm going to end the meeting now.
Okay, thank you, Steve.